The next topic in the chapter of triangles is isosceles triangles. So let us first look at what is the definition of an isosceles triangle. A triangle which has two sides equal is called as an isosceles triangle. So that means two of the sides of the triangle have the same length. In that case, we get what is called as an isosceles triangle. There are some properties of isosceles triangles which we will study and then use those properties to solve problems and to see different properties further in the chapter, and also to prove the congruence of triangles. Okay, so let us see what do we mean by this. So if you look at these two triangles here, it has two of the sides are having the same length. Okay, in this case the third side also looks the same length but need not be. For example, if this side is equal to this side, it is an isosceles triangle. Similarly, if this side is equal to this side, or if this side is equal to this side, so if any two of the sides of a triangle have the same length, we call it as an isosceles triangle. And with regards to an isosceles triangle, we have a couple of theorems. These theorems are the converse of each other. So if you know one theorem, you can write down the converse by reversing the statement, and you will get the converse theorem. So the first theorem with regards to the isosceles triangles is that the angles opposite to equal sides of the isosceles triangle are equal. So that means if we have an isosceles triangle which has two sides of the same length, so I'm marking the sides which have the same length by this black dash. So we have a triangle here, A, B, C. Okay, so in triangle ABC, the length of AB and the length of AC is the same. So we have two sides of the same length. And what the theorem says is, the first theorem says is, if two sides are equal, then the triangle is an isosceles triangle. And in this case, the angles opposite to the equal sides are also equal. That means the angle opposite to the side AC is angle B. So angle B is the angle opposite to the side AC. So AC is one side. Opposite to that side is the angle B. Similarly, the angle opposite to the side AB is going to be the angle C. So angle C and angle B will also be equal. That is what this theorem is telling us. Okay, so that's the first part. The second part of the theorem, or the converse of the first theorem, is that if we have a triangle ABC, and if we say that two of the angles for the triangle are equal, so if we say that angle B is equal to angle C, theorem 2 says that the sides opposite to the equal angles are equal. So that means the side opposite to angle B is AC, and the side opposite to angle C is AB. So it says that AB and AC will have the same length. So these are the two theorems with regards to an isosceles triangle, and we will use this in proving the congruence of triangles and also proving and solving other problems related to triangles. Okay, so if we have two sides which are equal in a triangle, the angles opposite to the equal sides are also equal. Or conversely, if the angles are equal, if two angles are equal, then the sides opposite to those equal angles are equal. Okay, let's do some proofs of these theorems. First of all, we will prove the first theorem, and then we will proceed to prove with the second theorem. And to prove these theorems, we are going to use the concepts that we have already studied for congruence, like SAS congruence, ASA congruence, and whatever. So whatever topics we have studied in the previous classes, we will apply those ideas to prove these two theorems, theorem 1 and theorem 2. So let us first prove the first theorem, which says that the angles opposite to equal sides of an isosceles triangle are equal. That means we are given that these two sides are equal, that is AB is equal to AC, and we have to prove that angle B is equal to angle C. So angle B is this angle over here, and angle C is this angle over here, and we are asked to prove that angle B is equal to angle C. To prove this, the first step that we will do is to draw a bisector of angle A. So we have the angle A here. We will draw a bisector of this angle and join that bisector on the line BC to meet it at some point which we will call as D. So let us draw a bisector of angle A. Let me do that. So that's the bisector of angle A. That means we are dividing the angle A into two parts. So that means this angle and this angle are equal, and they are equal to half of the total angle of A. So AD, and let this bisector of the angle meet the line BC at some point which we will call as D. So AD is a line that is bisecting the angle A. And we now want to prove that angle B is equal to angle C. Okay, that means they are the angles which are opposite to the equal sides, and we want to prove that they are equal. And to prove this, we are going to look at these two triangles, triangle ABD and triangle ACD. So we will look at these two triangles and check for their congruence. And once we prove their congruence, we can then apply the CPCT rule, which is the corresponding parts of congruent triangles, to show that the angles B and C are equal. So let us see the triangles ABD and triangles ACD. So in triangle ABD and triangle ACD, we want to show which parts are equal to prove congruence. So the first thing is, we know that the side AB is equal to side AC, and we know that the angle A is bisected by this line AD. So that means the angle BAD and the angle CAD must be equal, because they are both equal to half of angle A. And then we have a common line for both the triangles, which is the common side AD. So in these two triangles ABD and ACD, the first thing we notice that AB is equal to AC. This is the given condition. AB equals AC. How do you know that? Because that is given to us. So that is given. Then we know that since we are bisecting angle A, angle BAD and angle CAD are equal. So angle BAD equals angle CAD. This is by construction. This is how we have drawn this blue line over here. So this is by construction. And we have the line AD common to both the triangles. So AD is a line, or the side, which is common to both the triangles ABD and ACD. So in both the triangles, we will say AD is equal to AD. It's the common side. So based on this, we have a side which is equal, an angle which is equal, and another side which is equal. So that is side, angle, side. So we can apply the SAS congruence rule to show that these two triangles are congruent to each other. So we will say that by SAS rule, we can say that triangle ABD is congruent to triangle ACD. Now, since these two triangles are congruent, we can say that the corresponding parts of the congruent triangles are equal. So the corresponding parts of the congruent triangles is angle B and angle C are one corresponding parts. So by CPCT, angle B is equal to angle C. So hence we have proved that the angles opposite to equal sides are equal. So in an isosceles triangle, if we have two sides which are equal, then the angles opposite to them are also equal. Hence we have proved angle B is equal to angle C, which is what we were supposed to prove. Let us now prove the second theorem, which is the converse of the first theorem. The second theorem states that the sides opposite to equal angles of a triangle are equal. So we are given angle B is equal to angle C, okay, and we need to prove that AB is equal to AC. The side AB is equal to the side AC, because AB is the side opposite to the angle C and AC is the side opposite to the angle B, and when two angles are equal, the sides opposite to the equal angles are also equal. This is the converse of the first theorem, and we call this as the second theorem. So let us prove this. To prove this again, like we did before, we will draw a perpendicular, not a perpendicular, we will draw a bisector of the angle A. So let's draw a bisector of angle A, just as we did earlier. So that's the bisector of angle A. So that means we are going to have this angle equal to this angle. So that's half of the angle A, and we are going to prove that our sides AB is equal to the side AC, and the meeting point of the blue line with the side BC, we will simply mark it as D like before. And let's try to look into the two triangles ABD and ACD, just like we did in the previous case. So let us investigate in triangles ABD and triangle ACD. Let's look at the parts which are equal and show that these two triangles are congruent. Once we show that these two triangles are congruent, then we can apply CPCT to prove that the corresponding sides are also equal, and then we can show AB is equal to AC. Now, to prove the congruence of triangles ABD and ACD, we need to look at the angle on either side of D, which is, we need to show what is the angle, say ADB and angle ADC, which is the angle over here and the angle over here. So let me mark that with a different color. So I'll mark this with this purple color, or let me use some other color. I'll use this orange. Okay, what is the angle here and what is the angle here? And we want to show what is the relationship between these two angles. Now, since the total angle inside a triangle is equal to 180 degrees, we have angle B, we have angle A by 2 here, and plus this angle should be 180 degrees. So ADB, angle ADB should be angle A, let me write it further away here, angle ADB should be equal to angle B plus angle A divided by 2, or I can write it as half of angle A, half of angle A. Similarly, angle ADC, which is this angle over here, can be written as angle C plus half of angle A. And since we know that angle B and C are equal, because it is given, angle B and angle C is equal, and A by 2 and A by 2 gives the same value. That means ABD, angle ABD and angle ADC will be equal. So the relationship between these two is equality. So angle ADB is equal to angle ADC. So we have these two angles equal, which I marked in orange. So now we can check for congruence. So the first step is we have ADB is equal to ADC, and then we have a common side. So the common side is AD equals AD. So you can write that as common side. And we have angle DAB equals DAC. Angle DAB equals angle DAC, because both of this are equal to the half of the angle A. So combining these, we get angle, side, angle. So by ASA rule, we get that these two triangles are congruent. By ASA, triangle ABD is congruent to triangle ADC. So once we prove that they are congruent, we can say now by CPCT, corresponding parts of congruent triangles, we can say that, by the way, make this correction, by ASA, this is ASA because it is angle, side, angle, right? Angle, side, angle, ASA, not ASS, okay? And then we have by CPCT, we can say that AB is equal to AC. That means that the sides opposite to the equal angles are equal. Okay, to prove this, we have used the fact that the sum of all the angles inside a triangle is equal to 180 degrees. So okay, and since the sum is equal to 180 degrees for all the interior angles, this expression over here should have been 180 minus angle B plus half of angle A. Okay, I forgot to write the 180 here, so it is 180 minus this part. Okay, similarly here it is 180 minus this part inside the brackets. Okay, so angle ADB will be 180 minus angle B plus half of angle A, and ADC will be equal to 180 minus angle C plus half of angle A. And since angle B is equal to angle C, which is given to us, so angle ADB will be equal to angle ADC, which is what we have written here. And then we can check for congruence. So this angle is equal to this angle, that's angle. Then we have a common side, which is the blue line for both the triangles. So AD equals AD. And then we have the bisected angle of angle A, which is angle DAB and angle DAC. They are also equal because they are bisected. It is the angle A has been bisected into two equal parts. So therefore, we have the ASA rule to prove the congruence of these two triangles, and then we will apply CPCT to prove that the side AB is equal to the side AC. So we will say side AB is equal to the side AC. Okay, so this is the proof of the second theorem, and the second theorem is the converse of the first theorem. We will next do an example for an isosceles triangle and use these ideas to solve or to solve a problem or to prove certain things that has been asked in the question. So let's do one example, and the example here is that we are given an isosceles triangle which we call as the triangle ABC, and in this triangle it is given that the side AB is equal to AC. So it's given AB is equal to AC, and we are told that the bisectors of angles B and angle C intersect each other at O. That means there is a line that is going to bisect angle B. So there is a bisector of angle B here, and there is a bisector of angle C over here, and these two lines intersect at some point which is given as O. So this point of intersection is O, and we are asked to join A to O. So we are asked to join A to O. So we'll join A to O like this, and then we are asked to prove that OB is equal to OC. We need to show that OB is equal to OC, and also we have to prove that this AO, this line, dotted line AO, bisects the angle A as well. This is what we need to prove. To prove this, first of all, we will use the theorems that we have seen in this lecture. So since we have the sides AB is equal to the sides AC, then angle B must be equal to angle C. Angles opposite to equal sides are equal. So we will have this angle, which is the total angle B, and the total angle C are equal. Since these angles are equal, we can also say that the bisected angles are also equal. So the angle over here and the angle over here, that is the angle that the line BO makes with BC, and the angle the line CO makes with BC, those two angles are also same, because it is exactly equal to half of the angle B and half of the angle C. And since angle B is equal to angle C, half of angle B and C must also be the same. So I have marked those equal angles by these double lines for the angles. And since these angles are equal, the angles OBC and the angle OCB are also equal, which is what we have written here. OBC and OCB are exactly half of angle B and angle C, and because B and C are equal, OBC and OCB are also equal, which is what we have written here. Now, once we have this condition proven, we can now look at the triangle OBC. In triangle OBC, so we have two angles are equal. In triangle OBC, two angles are equal, and we saw in theorem number 2 that if two angles in a triangle are equal, then the sides opposite to the equal angles are also equal. So that means this side is equal to this side, because OB is the side opposite to angle which is shown here, and OC is the side opposite to the angle shown here. So OB is equal to OC because they are the sides opposite to the equal angles. So let's write that. In triangle OBC, OB equals OC. Sides are, why do we say that? Because these are sides opposite to equal angles. So this is what we had to prove in the first case. So the sides opposite to equal angles are equal, and based on that we have now proven that OB is equal to OC, which is exactly what is the first part of the question. We had to prove OB equals OC. The next thing we need to prove is we need to show that angle, the line AO bisects the angle A. To show that, we will look at two different triangles now. So we will now look at the triangle AOB and the triangle AOC. So this triangle on the left and this triangle on the right. We will look at these two triangles and show their congruence. Once we are able to show that these two triangles are congruent, then we can show that this angle over here and this angle over here is equal by applying CPCT. So we will look at triangle AOB and triangle AOC. So in triangle AOB and triangle AOC, what can we say about the different sides and different angles? So we know first of all that AB is equal to AC, which is what we have taken because that is the given part in the question. So AB equals AC, and then we know that the angle ABO is equal to angle ACO because it's going to be half of angle B and half of angle C, and since angle B and angle C are equal, half of angle B and half of angle C are also going to be equal. So it is going to be this particular angle which I'm marking here, this angle here, and this angle over here. these are equal. Okay, which I marked with pink. So that's our next part. So you'll say angle ABO is equal to angle ACO, and then we have OB is equal to OC. OB equals OC, which is what we have proven just a little while ago. OB equal to OC, which we proved earlier when we looked at this particular triangle, right? So OB equal to OC. So we have a side which is equal, an angle which is equal, and the next side which is equal. So we can apply the SAS rule, side angle side rule. So by SAS, we can say that by SAS, we can say triangle AOB is congruent to triangle AOC. So once we have that these two triangles are congruent, we can then apply CPCT, and then we say by CPCT, the angle over here, which is bisecting, which is divided by the line AO, the angle to the left of the line AO and the angle to the right of the line AO, they both are equal. So we can say this angle over here is equal to this angle over here. So by CPCT, angle BAO and angle CAO are equal. Angle BAO is equal to angle CAO. So that means the line AO is bisecting angle A. So therefore we can say that, let me write the rest of the part here. So therefore AO bisects angle A, because angle BAO is equal to angle CAO. So that means AO, the dotted line here, is bisecting angle A.